Secure and privatize your connection with NordVPN with its extensive server list and simple application which is compatible with all your devices. Check the link in the description below.
All DemmSec videos are for educational purposes only. Techniques shown in these videos should only be used in lab environments or environments where authorization has been provided. What's going on, guys? It's Dale here from DemmSec, and today I'm going to be taking beginner hacking instead of Aaron, and we're going to be talking about payloads and listeners. So I think the two best examples out there of what payloads and listeners kind of can be is Metasploit Framework, of course, and Empire. Empire kind of represents the way things are going, the way pen tests and social engineering is kind of being done now. So first, what exactly is a payload? Well, a payload is essentially what you want to drop onto a target machine once your exploit is successful. For example, if you're exploiting a buffer overflow vulnerability where the developer has forgot to check the length of your user submitted data before putting it into a buffer, then you can actually overrun into executable memory. And at that point, that's where your payload comes in. That's what you're able to execute on the other machine. And a lot of the times, this shellcode just pulls down a bigger payload, which gives them more access, which is kind of what the staged payloads in Metasploit do. And a staged payload just basically means that there's initial exe which runs, or an initial piece of shellcode which runs, which purely goes out to the internet, calls back to your C2 server to get the rest of it where it can load into a bigger piece of memory which is available for execution. Empire, on the other hand, doesn't really focus much on exploitation, more the post-exploitation, so it's a more rounded piece of software for doing post-exploitation kind of things. And by post-exploitation, this can kind of change depending on what you're doing. If the goal of your pentest is to show that you can access card details within a PCI environment, then that's going to make you, it should get some cogs turning in your head about what kind of C2 are you using. Are you going up against mostly Linux machines? Then maybe Empire's not such a good idea, because Empire's more full features towards PowerShell and Windows systems. Or are you on a system that's likely to have up-to-date antivirus where Metasploit payloads have all already been signatured and are very unlikely to be able to run? And these are the kinds of things you actually need to get in the recon stage, and Aaron's covered a bit of that in Nmap and understanding the system that you're trying to target. So today we're going to be looking at creating payloads and getting them onto a system so we can actually test out some of the features, and we're going to compare the different types of payloads that you're going to use on a day-to-day basis and how they vary, and certain considerations about each of them. So my first recommendation when making payloads for Metasploit in particular is to go ahead and get MSF Venom Payload Creator, or MSF PC. And to do that, if you just go over to the link in the description, which is this MPC link, it used to be called MPC, now it's MSF PC. Don't know why, but that's just how it is. And if you just scroll down this page a little bit, you'll get to right about here. And all you have to do in your Kali machine is to copy this command here, and then copy this command here, and paste them both into Kali. And once those are done, you can then use MSF PC. So I should probably mention the ways in which these kind of differ. Metasploit, most all the payload generation is done outside the application if you're not using any of the inbuilt exploits. If you're using an inbuilt exploit, it often will generate a payload and automatically start a listener for you, but a lot of the time you won't actually be using exploits within Metasploit unless you're in, a really weak network usually. So with MSF PC set up, I'm actually going to open another SSH session to my remote servers. So I'm SSH'd into a VPS now, and this is just for the demo. You don't have to use a VPS or anything. You can do this all with virtual machines and set up your own little Windows network that you can go ahead and compromise. So I'm going to use MSF PC to create probably the most standard type of payload out there, and it's a Windows reverse TCP interpreter shell. And to do that, all we have to do is MSF PC Windows reverse TCP, and then a port, and I'm going to go for 8080. And then it's going to give you the option of selecting which interface to use, and in this case my WAN and ETH0 are both the same interface, so I'm going to go for that. And then it's going to generate an exe, and you can see I've already done this a couple of times, so it's going to overwrite it. But it's going to generate an exe which we can then run on the target machine to get access to it. MSF PC also will make a handy command here that you can just copy and paste, which will automatically start Metasploit and create a listener, but we're going to do that manually just so you get the kind of idea. So with the payload created, we can head back over to MSF, and I'm just going to increase the size by, just a little bit. And we're going to use the exploit multi-handler, which is exploit/multi/handler. And this is going to be your probably the go-to thing if you're doing any kind of payload generation outside of Metasploit framework. So if you've used MSF Venom or MSF PC in this case, which is, you know, just a front end to MSF Venom, but just makes things a lot easier, you're going to be using the exploit multi-handler simply because this is purely made for you to create listeners for specific payloads. So we're going to essentially copy the payload that we've just created. So if we set payload to Windows Meterpreter reverse underscore TCP, and if you know that you're using a Windows payload, MSF PC defaults to Meterpreter. So if you go to here and hit tab a couple of times, and it might take a few seconds here, it's going to list all of the different types of Meterpreter payloads that are available, like it has done just there. So if you know from the file name here that it's using reverse TCP, but you don't know, is it reverse underscore TCP, is it reverse dash TCP, whatever, you can just do tab here and you can see here that it's reverse underscore TCP. And with that set, we're then going to type options, which is going to give us a list of what we have to set and whether it's required or not. So the L host is going to be the host IP address of the C2 server or the VPS we have running Metasploit. So to get that, you can either copy it from your previous command, which I'm going to do because it's just here, or you can do ifconfig right here from inside Metasploit and it will give you your local IP address. So we're going to set lhost to that IP address, and we set the port number with MSFPC to 8080, so we also need to replicate that here. So we're going to set lport to 8080. We're then going to run one more command, which essentially means the listener will keep running even after it has a session. So if we would send this as like a macro weaponized Word document, it wouldn't stop listening for sessions after the first person has listened, so it basically makes the payload really usable. So to do that, set exit on session, all one word, false, and then we could do exploit -j, which will run that listener as a background job, so it's now constantly listening. So I've now got a Windows system open and I've transferred all the payloads that I've created so far, and these are the ones we're going to be running through. But we have the reverse TCP payload that we created with the MSFPC command earlier. We also have Wireshark running, and we're listening for any packets which have the IP address of our remote server in, just so we can have a look at the kind of stuff that's going on. So I'm just going to double click on this exe and it's going to run, and you'll see on the left that a Meterpreter session opened. And then in Wireshark we can see a whole bunch of traffic going to and from this server, and if we scroll down, it is, you know, pretty constant traffic going back and forth. If we actually start interacting with a shell, and this will kind of show you some of the like session management within Metasploit. If you do sessions-l, it'll list all the sessions that you have currently open, all the shells on remote systems you have, and it'll show you a little bit of information about them. So in this case it's Meterpreter x86 Windows, so it's running 32-bit, it's running Meterpreter, and it's a Windows system. It'll show you their domain and username, and if they're not on a domain, it'll just be their username, their host name, and basically the route they've taken to you. So it is directly from our listener to the remote system over this port. It's pretty simple. You'll also see its internal IP address, which is, you know, really useful information because it can give you an idea of the size of the organization, or even just the kind of ranges that are in use. So to interact with it, we do sessions-i for interact, and then 1. And you get this 1 from the ID here, this column here, and we'll see we've only got 1 open, so it's fairly obvious. But if you have a lot of them, it can be very useful. And then if we just open a shell, which is basically a remote command prompt now on the other server, if we do dir, we'll get a list of all the files. And if we actually go to this machine, we'll see that we've, you know, sent quite a fair few different packets back and forth. And I could have a look inside of these packets, but there is some kind of encoding going on, and, you know, they're not human readable, but they're not encrypted either. So that means anyone with knowledge about how these Meterpreter packets work can look in here and actually see the data being sent back and forth. So that's one consideration to keep in mind. Do you need an encrypted payload? if you're doing a pen test for a customer, I always err on the side of using an encrypted payload, just so if you are pulling any data back out of the network, or if there is anything we're looking there, there's just no risk of anyone being able to compromise the actual session itself and gain access to the other person's machine. I almost also always use reverse payloads only. I think bind payloads can be quite risky, especially the more simple ones where you just kind of run it on the remote machine and it opens up a port on it. Because if it's not encrypted and doesn't have any kind of authentication, now anyone with knowledge of that can just send commands to their machine, and if that's a customer's machine on the internet, that's not a good thing. So what do we do if we want to use Metasploit? We've decided we want to use Metasploit and need an encrypted payload. So we have two to choose from. We've basically got HTTP and HTTPS. HTTP obviously isn't encrypted, but the HTTPS is an encrypted version of the same thing. So we're going to create two listeners now with Metasploit using the same method for both of these, and then compare the traffic we're actually seeing. If you ever want to go back to Metasploit console and you're in Meterpreter, you can just type background and it'll put it back into the background and you can continue with what you're doing. So first let's set up that HTTP listener so we can see what the standard HTTP traffic looks like. So we've already got everything configured except the payload. So if we do set payload, Windows, Meterpreter, reverse, HTTP, and options again, and you'll see it's using L port of 8080, which we need to change because if we look at the payload again, which we generated earlier, it's using 8081. So let's set the L port to 8081. And we also already have exit on session set because we're using the same multi-handler, so we can just do exploit-j, and that's now started that listener. So if we go back to the Windows machine and execute the HTTP one, we'll see Metasploit session 2 is opened, and we'll start seeing a bunch of traffic here. So I'm just interacting with that new session that's just opened, and the HTTP payload is already more stripped down than the reverse TCP. I had no option to run a shell command or anything like that. So these are the kind of caveats that you should be playing with and getting familiar with, so when you actually use one of these payloads, you're not really surprised by anything. If you've opted to use a reverse HTTP and then down the line are like, oh damn, I really need that feature but it's not available in it, then that's something you should have been aware of beforehand. And this is where kind of just playing and doing what I'm doing here, where you just generate a payload, put it onto a virtual machine, and then play with it, see how it differentiates from other ones. So you can see I'm actually having a bunch of issues with this payload, and as I said, play with these things, see what's wrong. And I was looking forward to having a look at some HTTP Meterpreter traffic, but in this case it just doesn't seem to be working. So with that kind of failing there, that reverse HTTP, let's set up another listener. So let's set payload this time to Windows Meterpreter reverse HTTPS, which if you are using Meterpreter, this is probably the payload I recommend using the majority of the time. It's encrypted, it's reverse, so it's coming out to you. It's probably the safest way you can actually get a shell out of a customer's network and pose very minimal risk. So if we do options again, we'll see we have to change the L port again, so let's refer to the payload we've already created, which is HTTPS 8082. So let's set L port to 8082, and we can just do exploit-j because everything else is set, and that's now listening. And if we go back to our other machine, execute this payload, as you can see we've got a whole bunch of traffic going back and forth as it's opening up the session. And now if we sessions-i free, we've now got a shell open on this other machine, and we should be able to do sysinfo and get information from the machine. And these packets now, they're still using TCP, but if we have a look inside, they're totally encrypted. The other ones look fairly similar because it's just kind of binary data, but encrypting it means that if anyone is listening in the middle with an intrinsic knowledge of Meterpreter packets, they now can't decrypt the data. And that would be really important if you were, penetration testing a PCI environment, card data flowing back and forth, and that's when you kind of use something like this. So there's quite a few reasons not to use Meterpreter and Metasploit for this kind of stuff. If you're on a system that's using pretty much any antivirus, it doesn't matter how bad it is, these Meterpreter payloads have been signatured out of the wazoo. Like, trying to drop one of these EXEs onto a system is really difficult, and I've got them here, but I've actually had to disable Windows Defender in the registry, totally disable everything, otherwise they just get eaten immediately. But one of the things that I find it really useful for is web apps. If there's any kind of file upload functionality, anything like that, I always find that Meterpreter payloads are always really useful for getting onto those systems and then pivoting in and all that kind of fun stuff. So I've actually generated one of these PHP Meterpreter payloads, and MSFPC, PHP, all this. It's basically the same thing. You just tell it what you want. So if you want a PHP payload, reverse HTTPS, or reverse TCP in this case, it'll just generate it for you. And one of the things you have to actually do here, which some people forget, is the PHP file that's generated has a couple of things commented out which you have to actually remove to actually weaponize it and have it, able to execute on a different machine. So I just thought I'd show you this before we move on to Empire here. But these two here you need to get rid of, and this one here you need to get rid of, and now this will actually execute on a remote system. Once more, we're going to background this shell here, and we're going to set up another listener. So set payload. Oh, it's opening another session from somewhere, apparently. So if we do set payload Windows Meterpreter, sorry, not Windows. So what you'll actually see here is we got a session to come in, and that's because we're on a system that has a public IP address, and the actual listening port is actually out there on the internet. And there seems to be systems that just crawl the internet and essentially intentionally infect themselves to basically verify that you are a Metasploit listener. It's kind of weird, but also kind of interesting, and just something to be aware of if you have a listener out there on the internet. I seem to actually get these every time I spin up a VPS with Metasploit, so not really sure what's going on there. So set payload, and instead of Windows, we're going to do PHP Meterpreter, and then reverse TCP, and then options once again, and we need to set the L port. And once again, I'm just going to double check on the payload I've already created, and this time it's 8083. And then we can do exploit-j once again to run that in the background, and that's now listening. So for example, I'm going to do this from the actual Windows machine because we don't need anything in particular. I have DVWA set up here on a remote server, and if I log in, and I'm going to set the security to low just because we're uploading a really obvious payload, but if we go to the file upload section, we can now, because I know that this application is PHP and been able to make a payload for that, just go ahead and upload this file, and it'll give us the directory here of how to get to it. And I'm just going to copy this and paste it up here. We're going to see that we get a session come in, and this is kind of the value on how everything ties back to reconnaissance. If you have a good idea of what you're trying to attack, you know the payloads that you can go ahead and build to execute on these remote machines. So now that we've covered Metasploit, quite thoroughly, let's have a look at Empire and see how it differentiates. So as I said in the beginning of the video, all the actual payload generation is done from within the console. You don't have to go out to a MSFPC or anything like that, which I find, quite nice. So first I'm actually going to type listeners and explain the kind of setup we've got here. So this is the actual local listener, and this is the IP address of the server that's running Empire. This here is a HTTP hop payload, listener, which our payload is actually going to call out to, and it's going to relay the traffic to us, which may seem, a bit silly. Why would I want it to bounce through another server before coming towards me? And it's simply because you might want to be more stealthy. There might be reason to hide your C2 server, and even when you're doing penetration testing or anything like that, you might actually have a scenario where a blue team or their SOC or NOC or network operations people are actually actively looking for traffic or trying to get your server shut down. And this allows you to, hop it through another server, and makes it, from at least the customer's perspective, they only have the IP address of a hop server. So if it goes down, you can just set up another server using this domain name, and keep the traffic flowing through it. So another thing to mention is Empire uses encryption on everything by default. Even though I'm only using a HTTP listener, the actual body of a HTTP request will be encrypted. So that's just a nice feature, knowing that everything's encrypted by default. You don't have to mess around with everything, and you can be sure that you're not exposing customers' information all over the internet. So to create a payload here, we're going to use Stager. And the reason I mentioned the listeners before is because you need to have a listener set up to use one of these payloads. And we're just going to go for Windows, and we'll just hit tab a bunch of times, and we're going to do launcher _bat. And at the time of making this video, Empire currently supports Windows, OS 10, and I think some very basic Linux support, but it has loads of different types of payloads, and kind of based off these payloads here, you can work out how Empire is actually targeted, like what its actual goal is. So you can see here we've got a bunny, so you can actually create bash bunny payloads with this, so you can plug it into someone's computer and gain access, that kind of fun stuff. You've got DLLs, which anyone who knows anything about Eternal Blue, very useful. You can make ducky scripts, same kind of thing, plug it in, types in your PowerShell payload for you, and you've got a shell. You also have these macro payloads here, so you can actually put a macro into a Word document and have it execute the macro when someone opens the document and you get access to their machine. So you can definitely kind of tell that this is more of like a phishing kind of social engineering tool, and I think it works really well at that, a lot better than Meterpreter and Metasploit for that particular use. So we're going to use Stager Launcherbar, as I said, and once we've selected that, we're going to type info, and if I scroll up a little bit here, you're going to see the only thing we're required to put in is the listener, which is the name of the listener that the payload's going to call out to. So in this case, we're going to set the listener to HTTP hop, and this is because that's what we want to be the first hop. Whatever you put in here is the first thing your payload is going to call out to, and we don't want it to ever call out directly to our server here, so it's all going via that hop server. And once we've done that, we can just type execute, and it's going to output to /tem/launcher.bat, which handily I already have on this machine here. So if I double click on this, you'll see a command prompt window pop up, and then in just a few seconds we should get a shell on here. It does take a little bit of time to come through, and there we go. So the one thing you're going to notice about this, if I go to agents, is we get similar kind of information. We've got a name, which is the same as the ID, internal IP address, machine name, in your network, but we also get a last seen. And the reason we get a last seen is because, unlike Metasploit, where you open your shell and it's constantly got a connection open, this uses HTTP to beacon out, and by default it beacons out every 5 seconds, but you can increase that to whatever you want. So imagine you've got a payload in a kind of company that's really on top of their security and they're actively looking for you. You may want it to only call out once an hour, or depending on what you're doing, if you've got a keylogger on that machine and you don't need constant access to it, you can just have it, send back the logs every day or every couple of days. If you're just looking for a specific password of an application that the admin logs into once every month, then you could just have it ping out once every day, once every month even, with just the information you need. So it gives you that flexibility, and it makes it far more stealthy, because if it's not calling out, then there's nothing really for them to find. It's kind of just sat there doing nothing at that point. If we interact with this GZ name, and we just do shell IP config, you'll notice that it doesn't run it straight away, and that's because it is beaconing out. So that's kind of put it in a job, and the next time it beacons out, it grabs it, runs it, and sends the data back, and we've got it back now. So what does this network traffic look like? So if we open back to our Windows machine, Wireshark, if we scroll down, we're not going to see any traffic for this associated with this 46 IP, and that's because it's never actually calling out directly to us, as I mentioned with the hop server. So if I grab the hop server's IP address and go into Wireshark again and do ip.addr equals this, and let it process over that, you'll see that we actually get HTTP traffic, and we can see here that it's using these these files exist. I had to put them on the hop server, but they're not real PHP files. It's just there to mask it as real traffic. So this is another option you have. If you're cloud fronting this through like a news website, you could literally copy their URL scheme, and to anyone looking, like in Wireshark like this, would never know the difference. So if I, let's follow one of these TCP streams, see if we can discern any other information from it. So if we scroll down, it's all encrypted, don't see very much, but we see the actual host there, so it is going direct to that hop.I'm in your network, which we set up for the listener. So guys, I hope this has taught you a little bit about, picking a payload, picking a listener, and, having some thought behind that based on what you've seen with Recon. If you did like this video, remember to hit like, leave any comments down below, any questions, I'll be there to try and answer them for you. Aaron's going to be covering more of what you do after this, so once you've got a shell, what kind of stuff are you looking for, all that kind of cool stuff in a future video. This is just kind of, giving you some ideas. This is something you should be doing. Spin up a VM, doesn't have to be Windows, set up an Ubuntu machine with a DVWA, try and make payloads to exploit it, just so if you are doing a pen test, you don't have to, research how to make a PHP payload, you just know how to make one immediately. And that being said, once again, thank you for watching, and I will see you next time. Bye bye.